Anthropic built their most powerful AI model to date and then decided not to release it to the public. In an industry where major labs race to ship frontier models to capture market share, this is a distinct outlier. Anthropic looked at what they had built, a model named Claude Mythos, and chose containment over distribution. Access to Mythos is restricted to a vetted coalition of about 40 partners, including major tech giants and financial institutions. Independent developers simply cannot access this API. This restriction marks a change in how frontier AI labs evaluate the risk-to-reward ratio of public deployment. To see where Mythos fits, we have to map out the current landscape of AI releases. This spectrum shows the current options. On the far left are open models, like Gemma and GPTOS, which use permissive licenses that allow anyone to download and modify them. In the middle are hosted frontier models, like GPT-5 and Claude Opus. These are gated behind an API and bound by safety filters. On the far right is a new category occupied solely by Mythos and its restricted coalition, known as Project Glasswing. The last time a major lab withheld a model in this manner was 2019, when OpenAI restricted the release of GPT-2. Mythos has forced the industry to establish an entirely new tier of deployment, driven by raw capability rather than commercial availability. At a structural level, Claude Mythos is a general-purpose frontier language model. It features a 1 million token context window. It operates with a knowledge cutoff date of December 2025. Internally, it sits in a performance tier entirely above Anthropic's current flagship Opus line. Its existence was kept quiet until March 26th, when a misconfigured content management system accidentally exposed a draft blog post. The leak forced Anthropic to officially announce the preview phase on April 7th. While the leak certainly generated widespread headlines across the industry, the true reason for containment lies hidden within the model's internal benchmark data. To measure that data, we can use Claude Opus 4.6 as the baseline metric. The first metric is SW Bench, which tests a model's ability to resolve real bugs in actual open-source repositories. This chart shows the performance jump. Opus 4.6 scores around 80.8% on SW Bench. Mythos scores 93.9%. The second metric is GPQA Diamond, a test of graduate-level reasoning. Here, Mythos achieves a score of 94.6%. Next is Terminal Bench 2.0, which measures how well a model can autonomously execute command line work as an agent. At base settings, Mythos hits an 82% success rate. When granted extended time limits, that score climbs to 92.1%. Across all these metrics, the data proves that autonomous agentic software engineering is now a realized capability, which introduces security risks. This brings us to the most critical metric, the CyberGem benchmark. CyberGem measures how effectively a model can find and reproduce software vulnerabilities. This chart highlights the gap. Opus scored 66.6%. Mythos scores 83.1%, a 16.5 percentage point jump. This benchmark is significant because every single point represents real-world security impact. It highlights a concept known as the symmetric skill paradox. Finding vulnerabilities is the same technical task for both defenders and attackers. For a defender, discovering a zero-day bug allows a team to patch a hole. For an attacker, that exact same discovery allows them to exploit the system. The skill is symmetric. In Anthropic's internal testing, Mythos autonomously discovered thousands of high-severity zero-day bugs. These discoveries spanned every major operating system, including Linux and OpenBSD, and every major web browser. In one instance, the model found a critical bug that had been sitting undetected in production software for 27 years. Anthropic's Red Team concluded that the model is capable of surpassing all but the most elite human security researchers at weaponizing software flaws. Releasing a model with this level of capability risks compromising global internet infrastructure. This symmetric threat led to the creation of Project Glasswing. The workflow has 3 stages. First, the model gets top-level access to the codebases of opt-in partners, including foundational cloud providers and OS vendors. Second, Mythos autonomously scans those massive codebases for novel vulnerabilities. Finally, findings are privately reported to partners for preemptive patching. These patches are deployed before anyone outside the coalition learns the bug existed. This closed-loop system allows the industry to use AI to fortify foundational software before the technical skills to exploit it are democratized. Capability gains directly created emergent risks, which forced a restricted coalition response. Mythos signals shift where raw capability dictates availability, prioritizing the stability of global infrastructure. For more breakdowns of technical AI developments, you are in the right place at This Will Surprise You. If you found this helpful, hit the like button, subscribe, and turn on notifications so you don't miss the next episode. The containment of Mythos establishes a specific precedent for how labs may handle models that possess these symmetric security risks.